So welcome everybody to this latest A-level video on 162 Maths, and in this video we'll be continuing with partial fractions with a look at how we deal with improper fractions. And this is when the degree of x on the numerator is either the same or bigger than the degree of x in the denominator. Now when you find that the degree of x is the same or higher in the numerator than the degree of x in the denominator, then the algebraic fraction is classed as an improper fraction and therefore will include a quotient in the partial fraction. Now this is the only amendment that you need to make when this is the case, after which you will need to assess whether you have 2, 3 or repeated function in the denominator and then follow the appropriate structure as shown in the previous videos. Now to gauge some understanding about how the layout all works, if we just take out some simple sort of algebraic fractions with degrees of x on both the numerator and the denominator, so when the degrees of x is the same like we've got in this example here, let's get a colour pen that actually works, there we go. So in this one here, then what you find, you've got x squared over x squared. Now here the degree of x is the same, so I've got degree equals 2, and here I've got the degree equals 2. Now when the degree of x equals the same, if I was to simplify this algebraic fraction, then that would just give me a constant. So that's just going to give me, let's say, a. Now and obviously if I had 3x squared over 4x squared, then that would just be 3 over 4. If I had x squared over x squared, then that's just going to give me 1. And if I had, let's say, 7x to the power 5 over 8 to the power of x over the power of 5, so if the powers of x are the same, I'm just going to end up with a constant value. Now if I then had x cubed over x squared, looking at this one here, then obviously the x, I'll end up with something involving x. I'll have a coefficient of x, whatever that may be. So for example, if I had 3x cubed over 4x squared, then that would be 3 over 4x, just x. Now obviously if I've then got something being added or subtracted to it, so for example like 4, and I've got let's say 4x minus 7, then obviously in terms of looking at the degrees of x, I'm going to end up with something x, and then obviously I'm going to get a constant as well. And likewise, if we've got x squared, x power 4 over x squared, then that's going to give me something x squared. Then obviously if I've got other things being added, so for example if I had x to the power 4 plus 3x squared plus 4x minus 3, and I add x squared minus 4x minus 8, then what I could then end up with is something involving x, then a constant, and that's where it could lead to. So these are the types of partial fraction elements that I then need to incorporate when I'm dealing with an improper algebraic fraction. So let's have a look at what the partial fraction would be in these examples. I'm not going to go on to answer these questions, I'm just going to show you how to set these questions up. So for this one here, we've got a degree of x of 2 at the top in our numerator, and if I expand the brackets, I'm going to end up with a degree of 2 at the bottom as well. Now here the degrees of x is the same, so what I'm just going to end up is with a partial is a constant. So I'm going to end up with a, which is my constant, plus b over the first bracket plus c over the second bracket, just like I did when I had two linear functions in the denominator. So the only difference is this here, is that because the degrees of x are going to the same, I'm going to end up with a constant. Now in some books or websites and other videos, you may see they going for the layout of a over x plus 7 plus b over x minus 4 plus c. Now there's nothing wrong with that. I'm not going to say my way is better than their way, but one thing that is to bear in mind is that the a's in this particular layout, a, b, c's, are going to be different to the ones that are set out here. So as long as you've got the right numerator over the right denominator and the right constant value, you're still going to get full marks depending on how you set it out. But me personally, I was always recommend going for this step here, trying not to write over the actual answer. So looking at this next one here, I've got a degree of x of 3, so just put d equals 3, and I'm also, if I expand the brackets, I'm also going to have a degree of 3 here. So again, I'm going to end up with a constant, and then it's going to be b over the first bracket, which is x plus 2, plus c over the second bracket, plus d over the third bracket. And then I could go on to follow my steps. For this third example here, if I just move the screen down, And let's go for a different colour. Let's go for blue this time. So looking at this, you can see that my degree of x is 3 at the top, but my degree at the bottom in the denominator is 2. So here, 3 take away 2 is going to give me 1, so I'm going to end up with ax, so a constant plus x, plus a constant, plus c over the first bracket, plus d over the second bracket. So the only thing that's different when I've got a, well, we could say a top-heavy fraction or a proper improper fraction, which doesn't make much sense, but hopefully you understand what I mean, that I would end up with this, and then I can then follow the steps. So looking at this next one here, I've got degree of x of 3 at the top and degree of x of 2 being at the bottom. So then this here would be ax plus b plus c over the first bracket plus d over the second bracket. So looking at this next example with a repeated root. Now here again the degree of x is 3 and the degree of x at the bottom is also 3. So what I'm going to end up with is a, so just a constant, plus, and then here I then got to look at the structure of a repeated root. So it's going to be b over 1 where you haven't got the repeated root. C is going to be 1 where you have got the repeated, where you've got the power, and D is going to be 1 where you haven't. Now, if the question was rewritten, so let's say we had x squared, 2x cubed plus 5x minus 18 over x plus 1, x plus 2 squared, then again what I would do is I'd write a, because I'll end up with a constant, plus b over x plus 1 plus c over x plus 2 without the power and d over x plus 2 with the power. So again, it doesn't really matter how you write it as long as you follow this. And this was again all covered in that repeated root video that I made previously. Now, if you were to get, let's say, a question where, let's say you had, and again, this is probably may turn up in a more of an exam style question, in a textbook question rather. So let's say I had 2x to the power 4 plus 3x cubed minus 2x plus 4 over x minus 4 x plus 5. Now here we've got a degree of x of 4 at the top and just a degree of x of 2 at the bottom. Now what this would therefore prove is that 4 take away 2 is 2, so I'm going to end up with ax squared plus bx plus c, and then the partial fraction element comes in. E over x plus 5. Now this obviously is going to be very, very time consuming, which is why in an exam, that last example is probably unlikely. However, in a textbook, because time's not of the essence and could give you a bit of a challenge to test your understanding, then you could easily get this type of question. Now obviously once you've set out your layout and broken it up into partial fractions, the next step is virtually exactly the same, and which what we'll do now is we'll go through some examples of how that applies to these questions. So as always, the best way of doing this is going through an example. So in this particular case, I've got 5x squared minus 71 over, and I've got two linear functions. So I've got x plus 5, x minus 4. So what I'm going to do, start off with my hashtag 1, is to write my partial fraction. So because this is, I've got degree of x at the top is 2, degree of x at the bottom is 2, therefore it's going to be an improper fraction. So I'm going to write a plus b over x plus 5 plus c over x minus 4. Now it's always important that you do write this stage, because when you find the values of a, b and c, you need to make sure that you do go in the right place. So here a is my quotient, b is the numerator over x plus 5, and c is my numerator over x minus 4. Again, if you were to write it as a over I'll put that random line there, so let's just quickly get rid of that. So if I was to write a over x plus 5 plus b over x minus 4, I keep doing that, and let's just get rid of that, there we go, and x minus 4 and plus c, so c is my quotient, and that's absolutely fine as long as I substitute it into that. So that's why it's really important that you do actually write this step down. Also, you also get a few marks for it as well. So from this, what I'm then going to do is I'm then going to multiply out the denominator over to the side. So in terms of hashtag 2, what I end up with is 5x squared minus 71 equals, and it's going to be a over x plus 5 x minus 4. Now a is always going to have whatever, well, your quotient is always going to have the brackets at the denominator because there obviously there's nothing that's going to cancel out, plus b over, that's going to have one that it doesn't have, and c over x plus 5. So from this, what I then need to do is find my values. So for this, bracket equals 0, x needs to equal minus 5, and for this one to equal minus 4. So when x equals minus 5, then what I'm going to end up with is 54 equals, it's going to be minus 9b, and so therefore b equals minus 6. Now just put a line through it. So when x equals minus 4, so when x equals, actually plus 4 I should say, don't know why I put minus 4, then what we end up with is on the left hand side we get 9 equals 9c, so c equals 1. Now in terms of finding the second one, well, there's a couple of ways in which you can do this. Now in terms of finding what the quotient is, I can either compare the coefficients. Now because a is my quotient, this is the only expression that's going to give me x squared. So the only way I'm going to get x squared is I'm going to have ax squared, and that's by multiplying a by x by x. So therefore by comparing the coefficients, a must equal 5. And that's from comparing the coefficients. Let me just write that down. So comparing the coefficients of x squared. And alternately, what you could do is just pick a random value of x. So when x equals 0, then again I'm going to end up with minus 71 equals, and it's going to be a 5 and then minus 4 plus b minus 4 plus c of 5. So if I simplify that, I get minus 71 equals minus 20a minus 4b plus 5c. Now I know the values of c and b, so I substitute that in and you'll get the same value of a equals 5. So once I've done that, what I then need to do is then substitute these three values that I found back into my original expression. So if I just drag this down in terms of my final answer, so just write down final answer, and then what I end up with is that a equals 5, so it's going to be 5 minus 6 over x plus 5 plus 1 over x minus 4. And there is my final answer. Now again, if I had any different arrangement of that, then that would be fine. As long as your quotient is 5, the numerator over x plus 5 is minus 6, and the quotient over x minus 4 is 1. So let's have a look at another example. This time we've got 3 linear functions at the bottom. So again, what I'm going to do is I write all of this, and that's going to be, just save a bit of space. And what I'm going to do is I'm going to have a again as my constant, a quotient I should say, then b over the first function, which is x plus 2, plus c over x plus 1, plus d over x minus 3. Now again, expanding the brackets out, or taking the denominator over to the other side, so in terms of hashtag 2, let's just label this as hashtag 1. So what I end up with is 2x cubed minus 2x squared minus 26x minus 18 is going to be equal to a lots of x plus 2, x plus 1, x minus 3, plus b lots of, it's going to be x plus 1, x minus 3, plus c lots of x plus 2, x minus 3, and finally d lots of x plus 2, x minus 1. So again, it's a lot of faff, a lot of writing out that we then need to do, but it's something that we then need to do. Now in terms of comparing the coefficients to work out what a is, well, a, looking at these, so comparing the coefficients of x cubed, then what I'm going to end up with is 2 equals, and it's going to be a. So therefore a equals 2. So then from this, what I'm going to do is work out the values of the brackets and make them equal to 0. So I'm going to use an x minus 2, x minus 1, and x equals 3. So when substituting those values in, so when x equals minus 2, then what I end up with is 10 on the left hand side and 5b on the right hand side, so therefore b equals 2. Then when x equals minus 1, so again what I end up with on the other side is I'm going to end up with 4 equals minus 4c, so c equals minus 1. What I'm doing there, let's correct that. And then for the final one, when x equals positive 3, then what I end up on the left hand side is minus 60, and that's going to equal 20d, so d equals minus 3. And there what I've got is I've got my final answer. So there I've got 2x cubed minus 2x squared minus 26x minus 18 all over x plus 2, x plus 1, x minus 3, and that's going to be the same as a, which is 2, plus b, which is 2 over x plus 2, minus 1 over x plus 1. Now it doesn't really matter if you put brackets around the denominators, but I always do. Minus 3 over x minus 3, and there is my final answer. So let's have a look at an example where the degree of x is different. So looking at this particular question, we've got a degree of x as 3 at the top, and we've got a degree of x as 2 at the bottom. So in terms of writing this out, I'll just quickly write this out here. So I've got 4x squared minus x minus 17 over x plus 3 x minus 2, and again that's going to be equal to, so here because I've got a proper improper fraction, it's going to be ax, because obviously the difference of the degrees of x is just 1, plus b plus c over the first bracket plus d over the second bracket. And there we go, and that is my step 1. Now in terms of step 2, what I then need to do is multiply both sides by the original denominator. So what I'm left with is x cubed plus 4x squared minus x minus 17 is going to be equal to ax, and then it's going to be x plus 3 x minus 2 plus b lots of x plus 3 x minus 2 plus c lots of x minus 2 plus d lots of x plus 3. And it's really important that you do write that down, because obviously that in itself will include a mark. Now when we get to step 3, this is where we start substituting values in. So to try and make the brackets equal to 0. So for this, x equals minus 3. For this one, x equals positive 2. And again, obviously the brackets are repeated throughout the other sort of values of a, b and c, so that's all I've got with. So for this, what we then do is substitute the values in. So when x equals 2, then what I'm going to end up with, substituting x equals 2 into the left hand side, I'm going to get 5, and looking at which letter disappears, it's going to be everything apart from d, so I'm going to end up with 5d, so therefore d equals 1, and there is my first value found. Then looking at when x equals minus 3, so substituting minus 3 into the left hand side, I'm going to end up with minus 5 equals, and then looking at which letter disappears, it's going to be everything apart from c, so I'm going to end up with minus 5c, so therefore c equals minus 1. Now in terms of finding the other values, now if you've set it up the way that I have, so for example you've set it up with ax plus b and then c over the first bracket, d over the second bracket, and if you had a third bracket then it would be, well, it wouldn't be an improper fraction with a degree of difference of 1, but we'll go through an example where that is the case. Now here what we can do is compare the coefficients. Now comparing the coefficients of x cubed, because that's the highest power that we've got, that here I've got 1 x cubed, so that's going to be 1 equals. Now the only, when I expand, if I was to expand out all these brackets, would be a lot of faff and it would be very time consuming, but if I'm a bit smart I can notice that the only way I'm going to get ax cubed is by expanding this out, and the only way I'm going to get ax cubed is by multiplying out ax by x by x. Now ax times x is going to give me ax cubed, so my coefficient of x cubed then is going to be a. So therefore a is going to equal 1. Now obviously what I can then do to find the third one, now you could think to yourself, well, the most obvious one is trying to find a constant, or try and find the coefficient of x squared or x cubed, x squared, or just x rather. Is that's going to be very time consuming, but also that if I just get rid of some of these little underlines, that you're going to end up with coefficients of x in all four of those expansions. In terms of x squared, I'm going to get an x squared in when I expand this bracket here, or these sets of brackets. I'm going to get an x squared when I expand that out, and so that could be one thing, but again, it's a lot of faff. The easiest way to go around it is by just simply substituting another random value of x. So when x equals, now again, I would either go for a small positive number or 0, as long as you've not used it in the previous one. So when x equals 0, then what I end up with is, well, nothing's going to disappear. So what I'm going to end up with is minus 17 on the left hand side, and then I end up with is minus 6b minus 2c plus 3d. Now you may be asking, where's the a gone? But because a is being multiplied by x, and if x is 0, then that's going to be 0, then multiplied by 0 gives you 0. So that's why a has disappeared. Now I already know the values of c and d, so substituting the values in, I get minus 17 equals minus 6b minus 2 plus 3, and then from this I get minus 18 equals minus 6b, so b equals 3. And lo and behold, I've now got my four values of a, b, and c and d. So in terms of writing my final answer, so in terms of step 4, I've got x cubed plus 4x squared minus x minus 17 over x plus 3 x minus 2, and that's going to be over a, which is 1, so it's just going to be x, plus b, which is 3, plus c, which is minus 1, so let's get rid of that plus and write that as minus 1 over x plus 3, and d is positive, so it's going to be plus 1 over x minus 2, and there is my final answer. Now if I didn't want to compare the coefficients of x, let's say I substituted x equals 1, then what you will find then is you'll end up with another expression involving a, b, and c, well, two of the letters, and one of them you don't know, and then I could use this method here in terms of this one to then look at simultaneous equations. So that's one way of doing it, but I would say coefficients of x, or the highest power of x, is going to be the most easiest way of finding that letter. Now when you find that letter, that doesn't have to be done third, it can be done first. It's entirely up to you when you order you do this, but again, just making sure that you've got the correct values of a, b, c and d in coordinates, and then substituting correctly into how you've written it in your original partial fraction sort of notation. So now let's have a look at this exam style question. So in this question it says that the curve C has the equation of y equals 2x plus 1 over x plus 2, where x is not equal to minus 2. Now the reason why they write this is because if x was minus 2, then basically our denominator would be 0, and obviously we can't be divided by 0. So, and the question is asking us to express equation C in the form of our partial fraction. So what we've got is, just write step 1, I've got 2x plus 1 over x plus 2, and that's going to be written as a partial fraction as a plus b over x plus 2. Now with this particular question, I'm going to show you what we do next. So exactly the step 2 is going to be virtually exactly the same. I'm going to multiply both sides by x plus 2. What I end up with is 2x plus 1 equals a of x plus 2 plus b. Now the problem with this is that when we look at the bracket, I want to make that equal to 0, just like we've done in all the previous examples, x equals 2. However, we've been told that x cannot equal minus 2, so therefore we cannot use x equals minus 2. So what we then need to do is we then need to find two other random values that I can choose. So what I'm going to do, so I'm going to choose two random values of x, and I'm going to say that the most easiest ones to use are going to be x equals 1. So if I let x equal 1, then what I end up with is 2x plus 1, so I'm just going to write this down so you can see exactly what I'm doing, equals a lots of 1 plus 2 plus b. So I end up with 3 equals 3a. 2. So it's going to be 3a plus b. And if I then let x equal 0, which is another easy value, so I've got 2 times 0 plus 1 equals a lots of 0 plus 2 plus b. I end up with, and it's going to be 1 equals 2a plus b. Now from this, what I've got is I've got simultaneous equations. So sim equations. So I've got 3a plus b equals 3, and I've got 2a plus b equals 1. I take the two things away, I get a equals 2, and if a equals 2, then b is going to equal minus 3. So from this, what I then get is that 2x plus 1 over x plus 2 can be written as 2 minus 3 over x plus 2, and there is my final answer. So let's have a look at another exam style question. So this one seems to be quite popular with more modern day exams. So let's have a look at the first one. Now first part, now this is basically a two-part question. So let me just start by writing this as A and writing this as B. Now question A should be relatively quite straightforward. So if I use partial fractions, I should end up with the answer of, and it should be 1 over x over 5 minus 1 over x minus 4. And that again should be relatively straightforward, and again if you want to practice with that then you can do so by pausing the video and rewinding. Now moving on to B. Now one thing the question says, hence prove that 1 over x minus 5 squared multiplied by x minus 4 squared is equal to this breakdown. Now in terms of this, the fact that it says hence means that we've got to use our answer in part A. Now one thing that you may have noticed or may not have noticed is that this on the left hand side of part B is basically this in our part A squared. So because obviously 1 squared is 1, x minus 5 is x minus 5 squared, and x minus 4 is squared is x minus 4 squared. So then in order to get this, then all I then need to do is square this, and that is what the question's actually asking me to do. So let's go along to do just that. So what this then equals is 1 over x minus 5 minus 1 over x minus 4, and that's going to be all squared. Now again, I always used to call this chocolate challenge in my class because I always used to get this wrong. Now you need to appreciate that this is a double bracket question, so this is going to be equal to 1 over x minus 5 minus 1 over x minus 4, and that's by another bracket of the same, which is x minus 5 minus 1 over x minus 4. Now it's going to be very easy to lose track of the signs of this because obviously we've got lots of minuses and we've got double brackets. So if you find that when you're doing these types of questions and your answer doesn't quite work, you may have an issue with signs. Now sometimes it's very difficult, particularly when you're doing like a page of working out, to spot where you've made a mistake in signs. And sometimes you may just have to bite the bullet and say, do you know what, I'm just going to do this question, start from scratch and go from there. Because sometimes you can stare at your working out and not see an error in your signage unless someone else is looking at it and working through your steps. So sometimes it might be best for you just to start all over again. But hopefully that doesn't come to this. So in terms of this, we just expand this out just like we did with normal quadratics. So I'm going to use loops. I'm going to do, or FOIL as you may use. So I've got 1 over x minus 5 multiplied by 1 over x minus 5 is going to give me squared. Moving on to the second one, I've got this, the first term in the first bracket multiplied by the second, so I'm going to end up with minus 1 over x minus 5 x minus 4. And then moving on to the second term in the first bracket and multiplying across, I end up with minus 1 over x minus 4 x minus 5, and then I end up with plus 1 over x minus 4 squared. Now from this, we've not quite made it look like what we want it to look like, which if I just get rid of those yellow loops, this is basically what I'm wanting. This is to make it look like that, and so far it doesn't. I've got two of the components, I've got this and I've got that, but the middle two, this bit here is what I haven't got. Now one thing you should spot, an eagle eyes of you will spot, that this and this is my answer in part A. So what I've then got is, if I just keep this on the side here, and let's just keep the yellow going. So I've got 1 over x minus 5 squared. Then I've got minus bracket, and it's going to be 1 over x minus, and it was, which went first, x minus 5 minus 1 over x minus 4 minus, again, 1 over, because this is part A again, I've got x minus 5 minus 1 over x minus 4. And then I've got this, which was from the original, which is 1 plus x minus 4 squared. Now here I'm not multiplying, I'm adding and subtracting, so just like collecting like terms. So my like, if I just get rid of those brackets, and I'll try and use the same colours just so you can see exactly what I'm doing. So that's x minus 5 squared, and then it's going to be minus 1 over x minus 5 plus 1 over x minus 4 minus 1 over x minus 5 plus 1 over x minus 4, and then I've got my plus 1 over x minus 4 squared. Now again, joining these like terms together, so these two are like, so what I've got is I'm going to end up with minus 2 over x minus 5, and then my other two like-minded terms, so let's go for orange. So I've got these two terms here, so I'm adding 2 over x minus 4, and then I bring my 1 over x minus 5 squared and my plus 1 over x minus 4 squared, and there is my final answer. And that's what they've asked me to prove. Now my order might be different to theirs. If I look at what I've written here, let's use different colours. So what I've done here is slightly different to what they've asked me here, but everything that's positive is still positive, and everything that's negative is negative, and that would still get me the same marks. If I really wanted to be prim and proper, I would write it the exact same way as what they've asked me in the question. But like I said, hopefully the marker, whoever's marking this, will recognise that it's both the same thing. 2 plus 3 is the same as 3 plus 2. It's the same answer and the same thing that they've asked me to prove. Now we'll put some practice questions in a worksheet in the description below for you to practice everything that's covered in this video with improper algebraic fractions and splitting those into partial fractions. I'll also include the answers, of course, so you can check to make sure that you are getting these right.